before we're going to build our on-prem storage vault, first some recap on how our architecture for on-prem storage works. And you see in this slide, I've got three major components in my network. I've got the internet, where all my partners or customers or even my employees will be when they are mobile. I've got the DMZ and I've got my internal network. So in this reference architecture, you see some components which will always be there in our environment. You have clients which can live on the internal network or on the internet. Typically that are my external collaborators, but, and this is sometimes overlooked, when I have users using mobile devices like iPads or tablets, they will be connected probably via a cellular network to our solution. We have the orchestration service, which is hosted by Syncplicity, and you see here in this reference architecture there might also be cloud storage, which we're not going to talk about today. If you have single sign-on, probably you have an identity provider, not in scope for this setup. So let's discuss what is really required to implement on-prem storage. Well, first of all, a load balancer, and that has two roles. It needs to typically terminate the SSL traffic, and it also is going to be used to divide the load over the available storage connectors. That allows our solution to be very scalable from 25 users to hundreds of thousands of users. The next, what we need is also storage, and you see here in the slide this can be almost anything as long as it supports NFS or S3. So how does this work? When I am using Syncplicity on my PC and I add a file to a Syncplicity folder, the client will detect that there is a new file or a change in a file. It will calculate a hash and it will ask the orchestration, do you already have this hash? We do this for deduplication. If the orchestration says this is not a unique file, this is a duplicate, my client will not even bother to upload it. Now the real magic happens when this is a unique file, then the storage connector will point my client over SSL to a URL to our storage vault. So each storage vault has its own unique URL, and this can be something like https mystoragevault.mycompany.com. So I will arrive at my load balancer, who will do the SSL termination typically and forward it on port 9000 to my storage connector. Some customers prefer to also have this traffic encrypted, and then we need to do the SSL encryption termination on the storage connector itself. That's a different topic. I'm not going to discuss that today, but we'll also be able to help you with that. When the file is going to be uploaded, Storage Connect will generate an encryption key and it will write the encrypted file on the backend storage. When the file is completely uploaded, and remember that we use chunking to make it possible to recap, to recover when a file transfer was interrupted. The chunking also allows us to keep the storage chunks pretty small. They're 5 megabyte maximum. So the encrypted file chunks arrive in your storage, and when the last chunk is successfully written encrypted on your storage, the storage connector will write the encryption key in our orchestration service. That means two things. There is no intelligence here. Our storage connectors are completely stateless. There is no database or anything installed here that stores your encryption keys. They're also only maintained here. And it also means that if something happens with these storage connectors, you just download a new appliance from a website, deploy it in your backend business. And also from a security point of view, there is no additional protection needed. You can safely store this storage connector in the DMZ or wherever you want. There's no preference from our side. Okay, so we now have looked at the architecture, and when you're going to implement your on-premise storage vault, you will have to agree with your people how the architecture will look like. Where are you going to place the storage connectors? In the DMZ or in the internal network? Where will your storage be? Which ports need to be opened? All that needs to be agreed, I think, best up front. You're going to start with the implementation. We also have another few things that are on our list. One of them is the fully qualified domain name for the on-prem storage vault. That will be a URL, something like this, https name of your storage vault.mycompany.com. And this is because all our clients will connect to your on-prem storage vault via this URL. Syncplicity only supports SSL, which means you're going to need an SSL certificate for the URL. That cannot be a self-signed certificate. It's something that we strongly discourage, and you typically also going to terminate the SSL traffic on the load balancer. So clients will talk to the load balancer, that will terminate the SSL traffic, and the load balancer will forward the traffic to the backend storage connectors. Those storage connectors are actually machine templates in the form of an OVA file that you'll download from our website, and you deploy them in your vSphere/ESX servers. You start them up, you log in, and when you log in for the first time with the user Syncp, you'll have to change the password. Optionally, you can also decide to change the password for root. Once that is done, you connect the storage connector to the network, you configure the network settings, and from that moment you can use PuTTY as your friend or any other Telnet client to connect to the storage connector for the configuration. You're going to provision storage in the form of NFS share or an S3 URL, and you're going to mount that storage on the storage connector. We're going to update fstab to do that mount during boot time. You need to open some firewall ports, configure the new storage vault in your Syncplicity admin console. That will give you an access key. And finally, we're going to configure the storage connector for this storage vault by entering the access key in the storage connector, and also connect the storage connector to the storage. When that is done, we're going to test it, and we're going to configure storage policies so that the new storage vault will be used in your environment. Okay, let's go. In order to give you a little bit background on how I'm going to set this up for my demo environment, I'm going to walk you through some of the items I have already performed. So looking at the reference architecture, I'm going to create a storage vault which is called Top Secret. The storage vault will contain all data that cannot be stored outside of our organization. It is data that definitely needs to be on-premise. For the storage vault, I have configured a URL, https sva.residencenewland.com. That's registered in my internal and public DNS. And I can accept traffic on that URL. It will arrive at the load balancer. On the load balancer for my demo, I have a wildcard. Of course, if you don't have a wildcard, you're going to require an SSL certificate for sva.residencenewland.com. And also my backend storage will be an NFS share, and this is the IP address and the NFS share name. Okay, so let's start and continue with the installation. So the next step in our installation is downloading the Syncplicity Storage Connector appliance, which is under the admin section under downloads. Make sure you log in as a global administrator. Click on downloads, and you will find here under the section Syncplicity on-prem storage vault links to our documentation and also the appliance OVA. It asks me for a location to save this OVA. I am going to save this in the temp folder, create a folder OVA, and this is where I will be storing that virtual appliance template. And now I have to wait for the download to complete. Once my OVA is downloaded, I'm going to the vSphere client from my ESX environment. I'm going to deploy the OVA. I'm selecting this from my file system, and I can then click next. It gives me more information about the version of the storage connector, size. I'm going to accept the license agreement, and I'm going to give this a name, on-prem storage connector. Right. I specify a data storage, and for the time being I'm going to then provision this, and when I'm done I'm going to power it on. It creates a task to import the OVA. I'm going to start the machine now, and we see that machine is booting. I'm going to give it a second to boot, and then we can start logging in and configure the network. Machine is started, and I can now log in. You log in with the user Syncp, and the password is on-prem, but you have to be careful. If you are not using a standard US keyboard, which is not QWERTY, like for me, I'm using an SRT keyboard, you need to blindly type the password as a QWERTY. And it asks me now to change the password. So first I'm going to type the on-prem password again. And now I need to choose a different password, which will be used as a new password for Syncp. We do that for security reason, and it needs to be a complex password, uppercase, lowercase, and also special characters. Then you need to retype that password again. And then when you have logged in, I did 2 failed attempts before this demo, so that's why I get a warning. I'm logged in, and I can now start configuring the storage connector. So one tip I want to give you, the root password is unknown, but if you want to change the password, you can do that by typing sudo pass wd root. It asks you for the default for the new Syncp password, and I can now change the password for root. Let's call that a little bit. And I can now, for example, choose a simpler password for root. It gives me a warning, and I can ignore that. That's not a problem. Okay, I have now updated the password for root. In case you want to perform actions as root, here is a way to change the password. You can from now on also change to root. And if you think, if you don't like the complex password for Syncp, you could, but I don't recommend you to do that in production environments, change the password for Syncp again. So in my demo, I would rather use the password on-prem. I'm going to ignore the warning, and I now have the password for Syncp set to on-prem again. As a next tip to help you with the configuration of the storage connector, if you, like me, are not using a United States keyboard and you'd like to have a different keyboard layout, you can change that. In the old storage connectors, there was a file in /etc/sysconfig keyboard file. And I've collected a few samples of how this keyboard file should look like. Since our new storage connectors that we use today, there it's even much easier. Under /etc/console.conf, you can change the key map variable with something different. So if you use a UK keyboard, it's just UK. And I've also listed a few of the other keyboards here with a link if your keyboard is not in that list. So now that I am in the storage connector and have changed my passwords, or optionally also updated my keyboard, I'm going to connect to the network. And in order to do that, according to our documentation, there is actually 3 files that I need to edit. This is the first one, which is the IFC FG-ETH0, which is my network interface card. I need to give it a static IP address. I also need to update the network file, which contains my host name and my gateway. And lastly, I also need to update resolve.com to point to my DNS servers. I'm going to do that right now. The first command I'm going to execute is this, which is actually specifying to my VM which network cards I'm going to use. I for insert. I'm going to delete this for a second. And I'm going to update the IP address to what is relevant for me, of course. For me, the IP address is 192.168.146. Of course, in your environment that will be different. I'm going to change the gateway to correspond to my gateway, which is 192.168.1.1. I'm going to delete this. And my network mask should be 255.255.255.0. And I also need to add the broadcast. Broadcast is for me the highest value of my IP range. I'm gonna let the boot pro to static, device ETH0 on boot, yes. I am using IPv6, so for me that's fine. Escape : WQ. I'm going to write that to the configuration file. And now I need to update the second file. This file is the network file, and here I can enter the host name of my storage connector. I from insert. I'm going to update the host name to SVA1, and I'm going to update the domain name to residencenewland.com. Here I'm doing exactly the same, escape : right quit. And finally I'm going to update the resolve.com file. And this file contains the entries to my DNS servers. I from insert. And as I don't have any other DNS servers, I'm going to remove all the other ones here. Escape : WQ. And this is saved. I can now continue with the documentation. And the documentation says that I now need to restart the service for the network. I'm going to do that right now. The service is restarting. And I can now check if I can, for example, ping one of my servers. I get a response from the gateway. So that means my storage connector connects now to the network. I have also configured my load balancer, and the load balancer will accept the traffic on the URL that I specified, sva.residencenewland.com, and it will terminate the traffic using my SSL certificate. For my demo, I'm using a wildcard certificate. The load balancer will forward the traffic, in my case, on port 9000 to the storage connector. That is done. My next step now is to connect the storage connector to my backend storage. The backend storage for me is an NFS share on a Linux server. And the backend is connected to my storage connector via this IP address. And this is the name of my NFS. Because my storage connector is now connected to the network, I can also connect to it via PuTTY. I have already created a configuration. I can now log in as Syncp, and you see that I can now nicely log in. I can now also use the full screen. So the mount is something that you typically do in fstab file. In the documentation on step 5, we need to mount the NFS share to Syncplicity. It is this command that we need to execute: sudo vi /etc/fstab. And I already prepared this. You see, I have already added this entry. I commented it, IP address, name of the NFS share, /mnt/p. This is where I'm going to mount it to, and I will later configure the storage connector to write the chunks to this location. I'm gonna save this, right quit. And if you want to do that mount yourself, you can also type the command directly here: sudo mount IP address, share name, and the mount point. When this works, you can test if you have the ability to look at that storage. I can go to that folder and I see that this indeed is a working mount. I can now reboot the storage connector, and the next time it will boot, it will automatically mount the NFS share to my storage connector. So I'm going to do that reboot now and wait for it to come up again. While we are waiting for the storage connector to reboot, I'm going to create my StorageVault. The StorageVault is that logical concept that we're going to use for our on-premise storage. Log in as a global administrator, navigate to settings and scroll down to the bottom of the page where you see manage storage vaults. I've actually created this one already and I'm going to show you how I did this. When you create a new storage vault, you give it a name that is a user-friendly name for administrators to understand which storage vault you're talking about. Optionally, you can also give a description for it. You assign a storage volume to it, and actually that is the same amount or less. And here on this section of the page, you're going to configure your storage connector URL. You add a URL, which is the fully qualified domain name for your storage connector, and you save that configuration. When you open the storage connector again now, you will see that it has generated what we call an access key. And this is the access key that we're going to need for our configuration file on the storage connector itself. So let's go now to the storage connector and see if it has rebooted. I'm going to use PuTTY again. I'm going to log in. And if you now look at our documentation, we're now at the step configure storage connector. We have to perform these configurations running this command, the sudo vi syncp storage. We will need the access key. We have got that. And if you are using a Syncplicity account outside the US orchestration, for example in Europe, you will need to configure the URLs to that orchestration service. And for me, because I'm using a generic NFS share, I need to specify in my NFS configuration the location for my mount point, which I'm going to leave as the default. When that is done, I also need to make sure, and this is a very important step, that Syncp storage becomes the owner of that mount point. And we'll do that in order to make sure that we can write to it, and also to make sure that no one else is able to access that location. Okay, let's go there. So I'm going to execute the command sudo vi syncp storage.conf. And here in this configuration file, you will see all the variables that I need to configure. The first one was the access key. The nice thing about PuTTY is that you can now do copy paste. So I'm going to copy the access key from my storage vault, press I from insert, and copy the access key. I don't have a proxy server. I'm going to skip that, and I need to specify the backend storage system that I'm going to use. In my case, this is a regular file system. Otherwise, you're going to choose either of those options. And also notice that we can use Azure and Amazon as backend storage. I strongly recommend you to turn on the encryption, AES256, which actually means that every chunk that's going to be written on your storage will be encrypted. Each file will get its own encryption key. I'm going to leave the compression for default, and because I have selected here as the file system FS, actually I don't need to do any change. I'm going to keep the root tier for Syncplicity to /mnt/syncp. At this point I am completely ready. I can skip all the rest, and also because I don't have an orchestration in Europe, I can leave this default. Otherwise, I'll have to add it here as well. That's a very important step if you're setting up the storage connector outside of the US orchestration service. I'm going to save my settings. Right click. And this means that if I now reboot the machine or I restart the service, and you see that my storage connector has now successfully restarted. I can now test if it replies to a command, and I can very simply open a new browser and navigate to the IP address on port 9000, and I'll add /ping to that. And I see that I get a reply back, which means my storage connector is operational. Now, if your load balancer is configured correctly, you can even try to use the fully qualified domain name, which is for me SVA residence Newland. And you see I also get a reply on that fully qualified domain name, which actually means that the connection from my client, from my browser or my desktop client or my mobile to the load balancer, and from the load balancer to the storage connector is working successfully. So the final test that I want to do is to see if I can really write files to my backend storage. So when we configured the StorageVault, we never had to say where or for whom it was going to be used. We just configured it. But in order to make sure that it's going to be used, we need to update our storage set policies. Storage policies are found under Admin, Policies, Storage Sets. Scroll down and you'll see you'll see a list of storage sets that you have already configured. If this is a new deployment or this is a proof of concept, you will see that there is one storage policy which is called the default storage set, and that will probably point to a public cloud storage from us in Europe, US, or any other region of the world. And what I now want to do is I want to create a new storage policy. I have already created this storage set. It is called Executive Storage Vault. It will point to my top secret storage vault. And this is for everyone who is part of the executives group. This is a day forward policy. Everything that was already on another storage vault will remain there, but only new created folders will be created on this storage vault. Okay, I'm going to save this, and now everyone who is an executive will now use my top secret on-premise storage vault. Now there is also another way to do this, which is very interesting if you just want to do a test and you don't want to disrupt anything. You can also create for a user, for example for Mr. Bob Sync, you can create a folder and point that folder to a certain storage vault. So if I navigate here to personal folders, I can then create a new folder, my SVA test. You see by default it points to my storage vault already, but if it would, for example, show to a different storage vault, I can easily modify that and point this new folder to this particular storage vault. I'm going to save that. And very important, it created the folder here in my user interface, but only when I click Save Folders, it really creates the folder. I already get a notification that there is a folder for me to sync. I can do that. Or I can go to the browser, Files, navigate to my folder, my SVA test, and I can try to upload a file. Let's take a test. And we see that the file has successfully been uploaded. So if you really want, you can now navigate to the backend storage and see if the chunks are stored over there. You can also navigate to the log file of the storage connector and see what it has stored over there. In order to do that, you need to have root privileges. So I will change to root, and I can now, for example, do a tail -f/var/log/syncp storage. What I did is I run the tail command, and you see that I tailed the log file for today. You actually also see here that I have been able to upload and download a file. Maybe let's do that test again. I'm gonna upload a new file. Maybe let's take this nice picture. And we see that the picture has successfully uploaded. And if we look in the log file, and we see here now in the log file that the upload has been successfully performed. The chunk has been uploaded, and it took it 319 milliseconds to upload it to the storage. So my actions is done. I have now set up a storage connector. I hope you enjoyed the session, and if you have any questions, please feel free to reach out to us. Thank you. Bye bye.